Hello, I want to walk you through every step by step process that I took in exploring the roller coaster datasets. So, firstly, I import the package. So, import pandas as PD, import numpy as NP, import cborn as SNS, import matplotlib.pyplot as PLT. Pandas offers structures and tools for effective data manipulation and analysis. NumPy is used for numerical data manipulation, processing, and analysis. Cborn is used to generate different type of plots like the heat bones, like the heat map, scatter plots, Bowling plots, and others. And matplotlib is used to create plots, graphs. The pyplot provide interface that is used to create or generate different type of plots. So import matplotlib.pyplot as PLT. PLT.style.use ggplot2. This line of code is used to create beautiful plots similar to the plot that is created or generated in R by using the ggplot2 package in R. So that's it. And pd.set_option in quotes display dot marks underscore columns 200. This line of code, when you read data into the data frame, if the columns are very much, so it will not return all the columns, it will omit some columns. So by using this line of code, all the columns will be displayed on the data frame. So we are telling Python the maximum numbers of the column must not exceed 200. So that is what this line of code is used for. So then after that we use pd.read_csv this file parts. So roller coaster dataset is a CSV files. So that's why I use read_CSV, and this is the file paths. That is where this particular file is stored in my local computer. This is the file path. That's it. So let me run this first. This one has been run. So this one has been run. Then we now want to check the shape of our data frame by running this. Oh my God. So this is our shape. The row is 1087 and the column is 56. That's for that one. Keep moving. So we now want to check how, since we have imported our data into the data frame, we now want to see or check how our data frame actually looks like. So we use df.head to display our data frame. So we now want Python to only return the first 5 rows. If you want to return the first 5 rows, you use the f.head. If you want to return the last 5 rows, you use the f.tail. So we indicate we only want Python to return only the first 5 rows. So that's what the argument is all about. And we have it, the first 5 rows. The next thing we just want to list out our columns. So this is it. def dot columns. So let me run it. So that's it. So this is our column. Coastal name is of object type here. Length is of object which is not supposed to be. Speed is of object is not supposed to be. The location is object. That one is okay. The opening date is object. It's not supposed to be. The type is object. That one is still okay. So that's for that aspect. We now want to use the describe function. This describe function is used to check the statistical summary of each of the column to have a better understanding of the distribution of data in each column. So let's run it. That's it. So we have the counts. So the count of the inversion is 932. We said earlier we have 1087 records or rows. So that means we have some missing values in the inversion column. We have missing values in the latitude, longitude, missing values in speed underscore one underscore values. Okay, in the inversion underscore clean, we have a complete values or entries there. So that's for that one. The mean of the inversion here is 1.547210. Also, you have the standard deviation, the minimum values for each of the column, the 25 percentile, 50 percentile, the 75 percentile, the maximum values of all the column. So that's it. To have a better understanding of the distribution of data in each of the column. That's what the describe function is used for. Let's run it. So that's for that one. The next step is to drop the columns we are actually not interested. I showed you earlier we have some columns like length is of string, the speed also there is of string is of string version, which is not supposed to be. So we need to drop some of the columns. Notice the length here is okay. We have the string version of the length here, the string version of the speed here. So we are not using that one. We already have the numerical version there. So it is that numerical version we are actually going to use. Let me continue scrolling it. Hey. Mhm, mhm. So we are actually interested in the speed in miles per hour. So we are going to use the numerical version of the speed and not the string version of the speed. So we are we are actually going to drop the columns we are not interested in. So to drop the column, we are going to use the F, then we use a double square brackets, then we insert the columns there in quotation, all the columns. So the one that's have hashtag, the line that have a hashtag will be converted to as in Python we see that as a comment. So it will not be read into the data frame. The ones that doesn't have an hashtag are the ones that we are actually interested in working with. All the blue ones or light green or something are the ones that are the comment that are the ones that the Python will see as the comments. The red one are the one that will be read into the data frame. So we now use dot copy. That means we have a brand new data frame and which will then be represented with the F. So let's run it. That's for that. So we now check the shape of our data frame again. It has changed. We now have 13 columns. So the next thing is we check the data type of each of the columns. For coastal name is object, which is okay. For the location is object is okay. For the status is object is okay. For the manufacturer is object is okay. For the year introduced is in 64 is okay. For the latitude is float 64 is okay. For the longitude is float 64 is okay. For type underscore mean is object is okay. For the opening date underscore column, it's not supposed to be object. So we need to convert it to date time. This for the speed it floats, for the height floats 64, for inversion claim in int, but this floats underscore claim is float. All these ones are okay, but for the opening date underscore column should be converted to date time. To do that, we use the pd dot to underscore date time. We use this df. So we reference the column we actually want to convert to data, which is the opening underscore date underscore column. So have I run this one? Okay, let me run this. Mhm. So it has been converted to daytime like that. The next thing is we need to rename each of the column. We know the columns, some of the columns are actually in lowercase, so we need to convert them to uppercase to make the columns or the table to be more readable. So this is it. We create like a dictionary. So column this comma here this. So that's how we now rename it. This is the previous name of the column, and so this is the name we actually want to rename the column with all this. So that's it. Let's run it. So that's for that aspect. Then now we return, check the data frame again to see how it looks like. So they are now in uppercase now. So the next thing we have to check for the null values. To check for the null value, we use the df dot is any. So, so that's it. Now the false. We have some true here. So that means all these one that have true. That means there is a null values in this particular. There is a missing value here. There is a missing value in some of these. So to have a better look, to actually know how many missing values we have in each of the columns. So we add dot sum to the line of code. So is it for the coastal name there is no missing value. For the location there is no missing value. For the status we have 213 missing values. For manufacturer 59 missing values. For latitude and longitude we have 275 missing values and others and that. So we now have idea where we have the missing values in each of the columns. So the next, have I run this one? Okay, so that's it. So the next thing is for us to now check for the duplicate records or the duplicate rows. So you can just use the duplicates. So these duplicates rows, so these duplicates we only returns the second and other additional rows where we have missing values, but we ignore the first row where there is a missing values. So we have this way false, 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 again, false, false. Then to have a better idea of where the missing value can be, we can run it on a subset of a column. So for this one, we use the coastal name. So by using the coastal name, we have true here. That means there is a missing value in this record, in this data frame. So the next thing we now do the lock. So by doing the lock, we have more better idea the records, where the duplicate records are. So by doing the lock, we realize we 90 so so we realize that we have 97 duplicate records. That means you have identical records or identical rows in the data frame. So that is for that. The next thing we need to know to so the next thing is that we need to know we actually decide the way we actually want to focus on we actually want to query it on a particular custom name. We choose the custom name, the coastal name. So we want to focus on any of the coastal name. So we use the Crystal Beach Cyclone. So by using the query function, the f dot query the coastal name is Crystal Beach Cyclone. We double quote this. So that's for that one. So by doing that, it returns two record for the Crystal Beach Cyclone, which is actually duplicated in Crystal Beach Park. Remove travel engineering for the manufacturer. Year introduced is 1926, and for this record is 927. I think others are still correct. So there is an error in the data. I think maybe it was due to when the roller coaster was put online, taken offline, then put back online. So I think that's where the error actually comes from. But we are actually interested in the first time it was introduced. Mm. Uh, so we now do this. We use this DM does duplicates. Now we want to consider more variables. So we use on the subsets of the coastal name, the location, and the opening dates. So shows we have a truth here. That means there is a duplicate records in this has true here. Uh, for that. So we now decide to have the total sum of all the duplicates, which is 97. So we now do the lock. No? So after this, we now do the inverse. The inverse is actually where we did not have any duplicates records. It will return where we do not have any duplicate records. Then we do the lock, which is then represented by the F. Let me run. Okay, I want to run this. Hmm. Everything has actually been run before. I'm just trying to run it again. Okay, I'm not really okay. So I think I stopped here. So everything is so everything this code is represented by the F. So we have this actually the datas where we did not have any duplicate rows. So we have 990 rows that are actually not duplicated. That's for that. Then after that, due to when we are dropping some of the records, the index are no more in consecutive order. So we need to reset the index. So let me run this first. Oh my god. My mouse is very sharp. I'm not double tapping it and my mouse is just too sharp. So so by using the reset underscore index, it will reset the index, it will create another index. It will create so we will now have like two index in that data frame. We are supposed to drop the previous index which is not in consecutive order. So we use the drop is equals to true to drop the previous index which is not in consecutive order, then dot copy. That means you have a brand new data frame which is then represented by the F. By running it, we have this. So we have these 990 rows that are not duplicated. So that is for that aspect. The next thing we now need to do the feature understanding. We are going to look at each features themselves to know what the distribution of these features and maybe some potential outliers are. This is also called the univariate analysis. So firstly, we want to focus on the year introduced, our reference on the year introduced. So the F dot year introduced. We now do the value counts. That means for each year that the roller coaster is introduced, we want to know the value counts. No, this value count is actually by by doing this value count, it will give the values of the years where the roller coasters were introduced in the same the value counts for each year. So it will now give the value counts in descending order. So we actually want the top 10, the the roller coaster was introduced, the top 10 when doing the value counts for each of the year. We actually want the top 10 counts. So we now use the head 10 to So that one will give us the top 10. Then we now do the dot plot. That means we want to create a plot, and the kind of plot we want is the bar charts. Then the title is the top 10 years coaster introduced. So we now represent it by AX. So after that, we now do the AX dot set on set underscore X label represented by the year introduced, and the AX dot set underscore Y label will represent by the count. Then PLT dot show to display the plots. So we have this the top 10 for the year 1999. The value count is close like 48 or something here, followed by which year is now 2000. So that's it. The top 10. The highest is for the year 1999. So that's it. The next thing is we try to create an histogram. So in creating by creating the histogram, we focus on the speed in miles per hour columns. We do the plots, and the kind of plot is the histogram. We now use the numbers of bins to be 20, and a bins is an interval or categories in which the datas are divided for the purpose of the histogram or frequency distribution. So that's for the bins, and the title of the bins is coastal speed. After that, we did AX dot set underscore X label speed. This one is just used to name x the x-axis as speed in miles per hour, and and then after that we plot our graph. Let's just run it. So the next thing is to create a density plot. A density plot is actually similar to an Instagram. Well, just change its kind is to KD Canal density plot. Then the title is this. We we label we give the x-axis a label by running this line of code. Then we plot is pl dot show. So that's it. So that's the the density plots for the in miles per hour. Then after that, if you want to create a scatter plots, so that's the f dot plots. Kind is the kind of plots you want to create is a scatter plot. The x-axis will be the what? The speed in miles per hour, and the y-axis will be the height in feet. The title is the coastal speed versus the height. Then we do the PLT dot show. Actually, we've actually started the feature relationship. We've done the feature understanding previously, like for the first three plots, we do the bar chart, the histogram, and the density plots. So we are now doing the what? The feature relationship. So this feature relationship is all about trying to determine how the features are related in the data set. So that's for that. Let me just run it. So that's it. So that's the scatter plots. Uh, the the speed in miles per hour against the height in feet. You cannot you can do the same thing, but this time around we are going to use the seaborne. The previous one we used the mass plus slavery, but this time I want to use the seaborne. The seaborne does scatter plots. X-axis will be the what? The speed in miles per hour. Y is at. So this time around we introduce another variable, the hue here introduced, and the data is there. That's our data frame. So that's it. That's it. The speed in miles per hour and in miles per hour against the feet. So we note that the one that the year, the points where we actually have a very deep purple is for 2000. So for the speed in miles per hour against the height in feet. So for this year now is for the 2000, which is between 100. I mean, the speed in miles per hour is close to 120. Let me just say like 175 against 354. So that's it. So this is deep. So it's for actually the 2000. So that's the scatter plot. Uh, and so then another thing, for the previous one we use like three variables. So for this one now we want to consider more variables. When you want to consider more variables, you can use the pair plot. So which we are going to use the seaborn. So SNS dot pair plots. The F is our data frame. So we now use the different variables here introduce speed, height, inversion, and g-force. The type of the material. So if we show the type of the materials, actually run this one. Everything has actually been run, but I just feel like running it again. Let me just run it. Go back. What was wrong? What was wrong? Okay, it's always take some little time before it will display. Let me try to take my time. So it has displayed now. Yeah. So we have the year introduced there, 1880 upward to 2000. Mhm. So here is for the speed in miles per hour. The one in red is for the wood. The one in purple is for the steel. So that's the top here are for the purpose. So that's how the variables are trying to relate with each other. The year introduced speed in miles per hour, height in feet, the inversion, and the g-force. So that is for that. The next thing we are going to do is we are still going to represent or try to relate the three variables again. So we use the double square brackets. We try to drop the missing values because we are trying to compare the variables. So we can't. So we need to drop the missing values. Then use the the core function to find the correlation between the three variables. So this for that. So for the speed against the year, the correlation is 0.17, which is very low. The the correlation between speed and the height in feet is 0.73. Speed and inversion is minus 0.029 and others like that. Okay, I've run it. So that's for that one. Mhm. So we can also represent it by using the heat map. So SNS does heat map the previous variable. That's it for the df.core where we find the correlation there. And not is equals to true is used to display the values on the heat map. I don't know why all the values is not actually. I've already run it. So I don't know why all the values are not actually showing. It's supposed to be showing on the heat map. So, so that is for that. The year introduced and the other year introduced speed, and that's it. So the next thing is we want to answer some question. What are the location with the fastest roller coasters? We want a minimum of 10. Uh-huh. So we first of all find the value count of the location. So the location for the other location which is not which the city is not actually indicated because it is represented with others. So that one is 181. The location is not indicated, only represented with order. We don't know the particular location one, so it is just represented with 181. For the King Island is 19. Cedars Point is 18. Six Flag Magic Mountain is 17 and others like that. So after that, we try to use the query function. We use the def query. With that we filter out the orders. We filter out the orders because we don't know the particular location, so we just filter that one out. Then we group by the location. Then so we use the speed in miles per hour. By using the speed in miles per hour, we actually want to find the mean and the counts of the roller coasters for each particular location. So we do that by using the aggregate function. So that value, so by running this, it will give us the average speed for each of the location and the counts. Then we now filter it, or we query is we want where the count of the roller coaster introduced for each location to be 10 and above, that is the minimum of 10. Then we sort by the mean. After that, we create a bar chart of figure size 12 by 5, and this is the title. So we then label our x-axis as average coastal speed. Then we then show it. That is what that one. Did I run the previous one? I didn't run it too. Let me run this. Let me run it. So that's for the two. So this is our horizontal bar chart, the average coastal speed against the location. So that's our exploratory data analysis. Thank you for your time.